Good morning. I wanted to give a quick lesson on solving ambiguous case triangles. We talked about solving triangles using the sine and cosine law before schools were closed, and if we had at least 3 pieces of information, we could always solve the triangle. And then we learned that that is always true except for one case, and that is if we have an angle side-side triangle. If we have these 3 pieces of information, we need to do a quick check first to determine if we end up with 0, 1, or 2 triangles. Because depending on what the angle, the side, and the side are, we can either not be able to make a triangle at all, we can make one unique triangle, or there could be up to 2 triangles possible. In any other case, if we had side, 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 or side, angle, side, there's always just one triangle possible, so we can just straight into solving and finding the missing piece of information. The first one I want to look at is if the angle given is obtuse, and we have 2 other sides. So if the angle is obtuse, we're going to start by drawing that triangle. We're going to draw the angle first. We have 100 degrees. This is going to be angle A. And side A is going to be across from here, connecting these 2 lines. So we can't really draw it yet. We need to draw side B first because it is connected to this angle. Convention, it's easy. We could draw it down here, but we usually draw side B over here. And this side is going to be however long it needs to be to connect the 2 sides we know. Now, side A, I want to talk about this case first because we have an obtuse angle here. Side A is only 6 long. Given this piece of information, if I have this line, let's grab a line. It's not as long as this 10. It's only 6. So it'll never ever be long enough, no matter where I draw it, to reach down to my last side. So in this case, we have no triangles possible. So if the angle is obtuse and side A is less than side B, we have 0 triangles. No. Triangles. Okay, if obtuse, side A is less than side B, 0 triangles. Now we're going to look at this. It's supposed to be let's make this a 16. So if we look at a second example, we again are going to draw our angle. We have an angle of 100 degrees. I'm going to make this side my side B of 10. Now, my side A, if I grab my shape, is definitely longer than this 10. So it's going to be out here somewhere. I can't draw it over here because that would change angle A. So this angle has to be out here. We know that this side is now 16 long. We now have a triangle we can start to solve. So from this check, if we have an obtuse angle and A is great, let's do it this way. Let's do it this way, use our math language. A is greater than B. If A is greater than B, we end up with one triangle. And we can go ahead and solve this triangle. Right? So those are the 2 cases for when the angle is obtuse. We just need to check, is A less than B or is A greater than B, 0 or 1 triangle. Next, if we get the angle is acute. Okay, we're going to look at what happens if the given angle is acute. So again, we're going to draw our picture. We're going to draw our angle in here of 60 degrees. Side B is 10 again. So this is angle A, this is side B. This side we don't know, this side we do know how long it is, but we don't know exactly where it goes, and then this side will connect with wherever it goes. So again, just for visualization, I'm going to grab a line. Now we have side A. It's shorter than 10, but it's just a bit shorter. And if we think about swinging this around, it's possible that it reaches, but we're not sure. So we need to do a quick check if the angle is acute as to the minimum length of this side, because no longer is the minimum length going to be the length of side B. We need to find what this straight down length is going to be. Because in this case, if A was 1, we're going to get no triangles. If A is super short, if A is less than this length, which we call the height of the triangle, there's no triangles. So we can put that point down right away. Let's get rid of this. So if A is less than the height we have no triangles. All right, so how do we find this height? Well, this height is always defined as the right angle from the bottom of the triangle. This triangle here is a right triangle. So if we call this height x, we can use over h. We can use our trigonomic SOHCAHTOA to solve this. Right? If we use SOHCAHTOA, we end up with sine theta. Review this if you have to. And we can use sine theta. This ends up being sine of our angle equals opposite is the height, and this side is our hypotenuse of this triangle, so 10. And if we go through and solve this, in this case, our height of this triangle is 8.66. So the length of this triangle is 8.66. Given this information, if this from this point to this point is 8.66 and our line is only A, we end up with 0 triangles. Okay? If we had, let's just copy this down. So if this was 9, move our summary down, we'll get to that in a minute. So now that this is 9, we're going to redraw our triangle. That's our angle A. Here we have 10. Because we know that this is 8.66, when we think of this line, it can reach over here, because it's a little bit longer, or over here. It can reach over here or over here. So if we have a case of where A is more than the height, we actually can end up with 2 triangles to a point. Because the other case we can think about is, oh, I need my line. If we know this line is longer than the height, we can have 2 triangles. But what if it's really long? What if it's this long? When we swing it around over here, it ends up being a totally different, oh man, that's really wrecking that. But if this line is really long, and actually if it's even longer than B at all, we end up with just a single triangle, because when it swings across, it would be too far. So the result is, if A is in between the height and B, you have 2 triangles. And then again, if A is more than B, you end up with more triangles. So in this case, we have 2 possible triangles. So I'm going to draw it in red, because this line of 9 could go here or could go here. So we need to be really careful when solving this. We need to look at more information. We need an additional piece of information to know, does my triangle go here or here when we're solving it? So we'll need more information to solve it. And so that is the result, an unsolvable triangle given the information. So summary at the bottom, if the angle A is obtuse, the only thing we need to check is side A less than side B? 0 triangles. If side A is greater than side B, 1 triangle. And we can have a little drawing here to help us out. Alright, so we have an obtuse. Right, if this side A is less than side B, we won't be able to make a triangle. If the angle is acute, we need to see how long. Is this one short enough to reach at all? Is it long enough, longer than the height, that it can reach twice? Or is it longer than B, that it's going to be just 1 triangle? And that is our 3 cases here. So that gives us a quick summary on the ambiguous case triangle. This information is also available in the OneNote, which is on Teams as well.